Hey guys, so today you and I are going to talk about senior code. So let's get into it. So the question in question was, Fredrik, at what level would you expect a senior's code to be? So I think that the first thing I want to say before going into the details is that, guys, I want to make something very clear. The difference between the code of a senior and a junior who has experience within working within a certain problem isn't all that big. Like, I know that this idea that being a senior, to some people that's like saying, oh, he's like Gandalf or like a wizard or something like that, that there's this big difference, like you're Harry Potter or you're Dumbledore, like these super big differences between coding styles, or that there's some magic to the code that a senior writes. This is not so. A senior writing software is no different from a junior writing software. There are absolutely things, practices, and certain small things that a senior might do, but it's actually very tricky to just read some code and feel this person here is probably a senior. Some things can give you a hint. There can be a maturity to the code, which is, so as an example, I'm just going to give you a few of these details. These are subjective, and the thing is that you don't have to be a senior to do these sorts of things. A junior could do them too, but usually what I see is that seniors do this at times and some seniors don't. Like this, it depends on person to person. And just because you do these things doesn't mean that you're a senior. So just bear with me, all right? So an example of a senior where you can see in the code that they are probably a senior is that they write the right amount of comments. They don't comment every single little thing. They write comments for code that is either very complicated or has some external dependency where you need to understand a context to understand a specific function. An example would be, let's say that you do a network call and it explodes for some reason. And then in a comment it says that, oh, you need to have this cookie in your browser, or you need to include this cookie in order for this network call to work because it's a third-party API or something like that. Or some helpful tip to make it easier for the person consuming this code to understand, oh, this is what went wrong, right? That's an example. Other examples is that they write the right amount of unit tests. They don't go crazy. An example of a junior making unit tests is in Java, it's very common to have getters and setters on your objects in order to get and set values on each object. Now a junior writing unit tests might write a unit test for every getter and setter. And depending on philosophy, this is really bad or this is very good. And this is a hint too that this person may not understand fully what unit testing is all about, depending on your philosophy regarding unit tests, of course. But the logic that they are testing there isn't super valuable. But a senior may not write those tests, but they might write a test for a function that does some search filtering or something a little bit more complicated, writing, as I said, the right unit test. Not all of them, just the ones that are truly testing the things that might actually break and are a bit of a issue area for regressions and stuff of this nature. Other things that you can find in a senior's code is that they write the right amount of abstraction. So mid-level programmers, they have this tendency to write what I call what-if code. And what-if code is that they are basically trying to either use a lot of patterns, or they're trying to upfront make things extremely generic or something like that, even when the use case today isn't really suited for that sort of abstraction. They're trying to, this is kind of the philosopher stage where they are writing code more for their own mental satisfaction than actually solving a problem. And what happens is that they might overcomplicate things or over-engineer things before they've actually reached a point where this is necessary. So it's a guess on their part. You can think of it in a similar fashion to buying insurance for earthquakes in a country where this has never been recorded to happen. It is sort of useful, but if you gauge these sorts of things incorrect, if you do the incorrect guess, or if you make the incorrect guess, you're just going to be left with a messy code, or that you're going to be left paying for something that you may never use, and it's just going to slow you down. Now a senior doesn't do that. They are much better at this when it comes to creating the right levels of abstraction and making reasonable guesses. But that ties into the thing that really makes a difference when you talk about the senior versus a junior's code, is the differences between a senior and a junior isn't always super clear at the code level, at just, you know, oh, they write the for function, a for loop this way, or they use a for each function, or whatever. This is not usually where you see it. Where you usually see it is in the experience, at the feature level, if you will, in the experience and the feature level of the person. So a senior, what the senior's real job is to make the right decisions on behalf of the project as a whole, or on behalf of their team. So a junior needs direction to do things correctly, usually, because even if you give a junior the chance to make all of these different decisions at a project level, odds are that they will make the wrong decisions, because they lack the life experience and they lack the general experience, let's call it that, to make decisions on behalf of a company that will pan out well in the end of things. These are usually the people who are going to cause you legacy and like all of these different problems that quite a lot of companies are trying to avoid. But the senior is supposed to have that experience because they are already on the other side of this. They have already fucked up, been there so many times when things have gone south, but they know that certain ideas are bad and some are good, but some are bad, and making the right decisions, that's on them. To give guidance to juniors and to make sure that they can manage stakeholders and actually create features that are stable, so that they have a, I'm not saying a project management type of deal, but it's a higher level. They need to take more responsibility for the quality of the software that is being produced than that of a junior, and they should, because that extra pay that they're getting, that's not just that they're usually faster in producing things. That should also be one of the things that they are giving to the company. But they, as I said, they need to have that more like the mature perspective, because they've seen things, they've been around the block, they know how things needs to work in order for the company to continue prospering with the stuff that is being produced. So what I want you to take away from this is that there is no magic to a senior's code. Sometimes you can see a certain level of maturity to software, and then you may think that that might be a senior, but it doesn't have to be a senior. There's quite a lot of seniors who don't write comments or doesn't like produce all that many unit tests and so forth, and that, so it's a very subjective measurement. What a senior usually distinguishes themselves with is their experience and these choices that they make on behalf of the company. If you have a real senior, which you kind of have to have if you're going to make a successful IT company, these people are usually the people that all the stakeholders come to and the juniors come to for help, or to get opinions about decisions that are being made, or they're there to set up roadmaps or prepare work for other juniors and so forth. And this is very natural because they have already built so many things that their experience will help them understand features quicker and to deliver software that will keep on working for quite some time. Have a great day.